Welcome back to my channel. Today we will be discussing in detail about the consensus algorithms in blockchain. So these consensus algorithms, they form the foundation to go ahead with any blockchain platform that we choose. A consensus algorithm is usually taken as a procedure or an agreement through which all the peers they try to adapt. So this consensus algorithm basically talks about the current state of the distributed ledger, which is a blockchain. Consensus algorithms also help to achieve reliability in the blockchain network, where the system will have the capacity to survive failures and even run in the presence of failed nodes. It also helps to establish trust between unknown peers in a distributed computing environment. We also have CAP theorem that plays a very prominent role. So CAP stands for consistency, availability, and partitioning. So the process of attaining agreement on a common state or value where there are multiple nodes in a network despite the failure of some nodes is a distributed consensus. So to achieve consensus, usually there are various requirements. So the first requirement is agreement. Agreement is like a consent of all the nodes which are honest and they agree to reach to a consensus based on some common value. Another important aspect, which is a requirement to deal with the consensus, is integrity. So, this integrity is basically a requirement which states that no node should make the decision more than once. For example, let me say if we have node N1, node N2, and node N3. So, if these nodes are performing transactions across each other in a network, and these transactions are performed by allowing another node to validate, like suppose if N1 is making a transfer to N2, then the node N3 will be acting as a validator, which will validate the transaction. So if N1 is making a transfer of, let me say, $10 to N2, then node N3 will have to validate whether it is a legal, legitimate transaction or not by looking into the ledgers of their respective nodes. So every node is even associated with a ledger. So here, when node N3 it agrees that N1 has made a transfer to N2, which is a genuine transaction. At a later point of time, node N3 cannot deny that it is a illegal transaction. That is where the integrity property will be preserved in a blockchain environment. So no node should make the decision more than once. Next important property to achieve consensus is validity. So validity is the value which is agreed upon by all the honest nodes and the nodes must agree to the value which is proposed by any one of the nodes, at least one of the honest nodes in the network. So this is the validity property. Another interesting property is fault tolerance. So the consensus algorithm should be able to run correctly even in the presence of faulty or malicious nodes. These malicious nodes in the network are known as Byzantine nodes. Termination. Termination is another important requirement to achieve consensus where the honest nodes should terminate the execution by reaching or by deriving at a conclusion. Based on these requirements, we have various consensus algorithms that we will be discussing. So this is how the consensus basically looks like. It is assumed as a protocol and it makes sure that every new block is added to the blockchain and one and only one version of truth is agreed upon by all the nodes in the network. So different types of consensus algorithms that are available is proof based consensus and traditional fault tolerance based consensus. Under proof based consensus, it works on the principle of providing proof of some work or possession of some authority or tokens to win the right of proposing the next block. As there are multiple nodes competing to add the blocks, multiple blocks competing to add the transactions, these all blocks have to undergo a consensus and they have to win so that they will be given a chance to add their transactions to the respective blocks. So these proof-based consensus are proof of work, proof of stake, proof of authority, proof of elapsed time, etc. Another category of consensus algorithm is traditional fault tolerance based consensus mechanism. So this is basically relying on a simple scheme of nodes that publish and verify signed messages in a number of phases. So there are two type of faults which this traditional fault tolerance based consensus deals with. First type of fault is fail stop or crash fault, which occurs when a node has crashed. And to enable the entire network to work in the presence of a fault node, Paxos and Raft are the familiar consensus algorithms. Another category of consensus algorithm which deals with the fault tolerance is Byzantine faults. So, the faulty nodes which exhibit malicious or inconsistent behavior is a Byzantine node, and identification of such nodes is difficult task, and there are certain consensus algorithms which are designed exclusively to deal with this Byzantine faults. So, practical Byzantine fault tolerant is an example algorithm which deals with Byzantine or malicious faults. So, in this video, we will be discussing about the proof-based consensus algorithms. So, coming to the first one, it is proof of work. Proof of work algorithm is used to select a miner which will be helping to generate the next block. This is exclusively used by Bitcoin. Ethereum initially would use proof of work. The central idea behind this algorithm is to solve a complex mathematical puzzle and to easily give out a solution. Here we have a network server and there is a puzzle. Let me say y is equal to f of x. What is the value of x? That is the question. Now the server or the admin, though it is a distributed environment, it has little elements of centralization in it. So this network will throw a puzzle across all the nodes who are actually trying to solve it, who wanted to add their blocks to the blockchain. So x1, x2 and x3 are the nodes which are acting as miner. Once they are solving the puzzle, they will be generating the solution and sending the response back to the network. And now the network verifies which of these nodes has responded accurately, and it checks with the solution and it identifies that the node x2 has resolved the puzzle and it is the miner. So the node which is resolving the puzzle will be given some rewards in the form of tokens, and that node will now be given a chance to add its blocks to the blockchain. That is how the proof of work consensus algorithm works. However, this puzzle, when is solved by the node, it consumes a lot of computational power. Another algorithm is proof of stake. So proof of stake is an alternative to proof of work, and Ethereum, which is a familiar blockchain platform initially which used proof of work, has now shifted to proof of stake. In this type of consensus algorithm, instead of investing in expensive hardware to solve a complex puzzle, there are validators. So these validators, they invest in the coins of the system by locking up some of the coins as a stake. After that, all the validators will start validating the blocks. These validators will validate the blocks by placing a bet on it if they discover a block which they think can be added to the chain. So, based on the actual blocks added, validators will get a reward that is proportionate to their bets, and accordingly, their stake will increase. In the end, a validator is chosen to generate a new block based on their economic stake in the network. Hence, proof of stake is a consensus algorithm which actually encourages the validators through an incentive mechanism to reach to an agreement. Another interesting consensus algorithm is proof of burn. So here the validators actually burn the coins where they are sending the coins to an address from where they are irretrievable. It is like making a long time commitment in exchange for the short term loss. Just like making a donation, earning a privilege and forgetting about it without expecting any returns is the mechanism captured under proof of burn. Similarly, we have proof of capacity, where the validators actually focus on investing in the hard drive capacity. proof of elapsed time, where every node gets a fixed amount of time to add their blocks to the blockchain, and various other consensus algorithms are available. In the next video, we will be discussing in more details about the other categories of consensus algorithms which deal with the crash and fault. Please like, subscribe, and share my videos, and subscribe to my channel. Thank you.